Hi everyone, it's a real pleasure to be here. I'm going to stand up on stage actually, and I'm not going to do the Todd Conklin thing or the whole side-on thing. I'm not fat. I'm working on getting fat. It's a real pleasure to be here and to have just 15 minutes to answer what is a question that's been going around the room for the last 2 days. It's all fair and well learning this stuff, but what do we do next? So I'm feeling like there's a lot hanging on my shoulders here. What I've got really is more of a story about my experiences doing safety differently, or safety 2, these new philosophies and trying to put them into practice. And I've just returned from Canada where we've been trying to do the same thing there. So I'm going to share some stories with you. But to get started, I want to share a story that's really cold. All right? I know you like it warm in here. Anyone know where that is? Just shout it out quick. It's the South Pole. It's near the South Pole. So I worked with the New Zealand Antarctic program several years ago and went down there with the task of introducing 18001 to the organisation. That was not going to be the case. What I went down there and found was this on the way down to the continent. Huge amounts of sea ice that move in and out, thousands and thousands of kilometres. Well, not thousands and thousands, plenty. Travelling down on US military aircraft, and we were a New Zealand entity, and I was wondering how the hell do we account for them, and do I go up to that big captain and ask him to see a certification? Not a good idea when they're armed. And then we get down to Scott Base, which is the New Zealand program down there, and in the background is a volcano, which is highly relevant of recent times, and it's active, so lots of things. Then we've got temperatures, that sort of, well, there it is, minus 20 or minus 30 ambient temperature, and that wind can change in no time at all, and suddenly it drops to sort of 40 or 50 below, and you don't want to get caught in that. You've got massive things like that. There we are in our little Hagland, traveling around the continent. You've got big pieces of glacial ice that break off, float out to sea, the sea ice reforms, and that glacier then stands there. And if you go anywhere near that thing, it's likely to tumble or turn or anything. And that thing is, it's the size of this hotel easily. And then you've got the wildlife. And they are beautiful, but they're also, the last fatality that the British Antarctic Survey had was a leopard seal attacking. These are Weddell seals, they're beautiful. We've got scientists working all sorts of different terrain. You've got ice, you've got rock, you've got snow, you've got the weather. And then you've got deep field exploration work. So we could be going 1,000 kilometers out to somewhere to do a drill on some ice cores that we want to get. And those guys could be traveling through and it'll be 400 meters thick of ice, and the next minute there's a crevasse. And this is what the guys have to put up with. They'll have a rig out in front of the machine, and they'll be looking at ground penetrating radar, looking for crevasses. The speed of the vehicle traveling and the response time to actually stop is about 4 seconds. Having an operator sit there all day long staring at a computer screen waiting for that beep is hard work. And having measures that say you should just try harder, you should just pay more attention, ain't going to work. So we put things like rumble strips and alerts and sounds, things that will awaken you to something that's different. But these guys also, if you notice, these guys are harnessed up, and there's a guy at the back of the machine there, ready in case this guy falls through the ice. They're actively practicing response measures. They're not waiting for it to go bad. They're ready for it when it does go bad. Now, they've got things like polar tents. These are still from the days of Captain Scott when he was down there in 1912. These things are brilliant. They've learned from them, they've improved them, and they're still highly relevant to today's operations. And they actually work. They're pretty cool. What I found when I was down there, and this is why resilience engineering is really important to me, and safety 2 is built upon those premise, is these 4 potentials were evident in the operation. They were actively learning. They weren't waiting until bad things happened. They were actively reporting every day, learning about what was going well, learning what was going differently. They were actively able to respond to things. They maintained that response presence. So we had a search and rescue team on standby the whole time, 2 helicopters, the American base next door, actively working on response the whole time. Because if something bad happens, if somebody, for whatever reason passes out on the ice, you have only got minutes to get to them and then get them back into the warmth, potentially. You go down on the aircraft and you wear big emergency clothing. We call them emergency ECW. What was it called? Extreme weather clothing. Sorry, extreme weather clothing, EWC. The other thing they're very good at is anticipating. So they're constantly looking for ways of what could go wrong, how could it go wrong. And they're also monitoring lots of different things. They're monitoring conditions, not the behaviors necessarily of people. Weather, they'll be monitoring, fuel caches and the temperatures of those fuel caches, so on and so forth. But the point I want to try and make here is that I called them a resilience organization, and the reason I did that is because resilience to me is a gestalt. And by gestalt, I mean you can't just do learning. And I think that's what everyone in the room has concluded from the first 2 days, is learning is not enough on its own. You can't do learn without understanding all these other aspects. You can be an organization that just does learning and you're not resilient. And a classic example when I'm consulting with companies is to ask them, do you monitor fatigue? And the guys will say, yes, we do. And I'll say, what does that look like? And they'll say, well, we get the timesheets at the end of the day or at the end of the week, and then we decide whether or not it was, it was fatigue, and then we adjust next week. And I'm like, well, that doesn't have a response mechanism really, does it? How does that tie to proactively monitoring fatigue? So I saw, when I got down there, something different. And it was this one thing they were very good at is they understood their work. They had this really good conceptual model of what work was going to be like at any given time on the continent. Whether it was a science experiment or it's a deep field operation, these guys had a good model of what was going to happen. And that good model was not leaps of paperwork. And I was really surprised. I went down there expecting to be lots and lots of paperwork. And this is what I saw. I saw experts in the field. This guy here, on the right here with the bald head, that's Richie Hunter. He's climbed Everest 6 times. He's only got to the top once. He's been involved in all those big incidents we've had over the years, but hugely experienced on the ice. We've got guys who do diesel mechanic work up in the Northern Territories of Canada, huge experience in those sort of operations. And what these guys are doing is they're talking about information, environmental information, where they're heading to, the sort of conditions they can anticipate, field reports from the Americans who are doing their field ops as well. And the guys are planning and talking and simulating work through conversation. They're creating a conceptual model that is being updated by learning. And that, I think, is a missing piece. When we talk about learning and taking all these things that we've learned from the field, it's not so much about putting them into files here and reports there. It's about how is that actually updating our conceptual model of work as imagined. Now, more recently, so I want to actually call this constructing work as imagined. Okay, it's not something that's out there, it's a social construct. It's something we create either in our own minds or as groups of individuals who come together through dialogue, or it is something that we construct based on other narratives, previous narratives, experience. But we construct it. And so what I want to talk about here is, this was a job I've just come back from Ontario, and the Darlington nuclear plant uses something called a CANDU nuclear reactor. And the task at the moment for the teams that I was working with, they are taking the core of that reactor completely apart, taking those parts, crunching them down, putting them into containers, shipping it out by remote control vehicles and so forth. These guys had never done it before. The designers of this had never considered that you would actually refurbish it. You would demolish it. So you have a conceptual model, and you have a load of known knowns and a load of unknown known or whatever. There's a conceptual model with gaps in it. So what the guys did is they invested $40 million into this, which is a full replica of the reactor. And when I went out and spoke to these teams, I said, well, what do you call it? And they went, a training simulator. And I said, okay, so training is the instruction of people in a process. And they said, yeah, it's kind of a two-pronged thing here. We simulate the work, and then we update the training, and then we can actually introduce the process and say, hey, this is how we're going to do it. But there were all these activities that were going on about learning from a simulation, debriefs. There was pre-starts, there were video recordings, there were all sorts of stuff that was going on to learn about what was successful in that work, what varied and so forth. But when we got to the actual work, it wasn't there. And I found that curious. I was like, there's a lot to be learned here about these methods that people were applying. But these were the sort of things the guys came up with. So in here are all the different fuel rods that go into the reactor. These guys actually are operating in one of those suits in very hot temperatures with air hoses trailing around everywhere. They soon realized that they didn't have the right equipment to do the job with, or there were special considerations, like having the hoses on the floor, not a good idea. Having them hanging overhead, not a good idea. Blowing cold air into them, good idea. How do we do that? All sorts of things came out in the simulation process. So the second thing that they found, well, this is just one of many lessons they learned. These I don't know if you can do the pointer, but up here you can see these tubes coming down, and these are the feeder tubes for the coolant water that goes in. And what they realized is that every single one of them couldn't be pre-manufactured. They had to be welded, and they had to be welded and connected in a certain order. It was agonizing work for these guys in a hot environment. So they learned all this in a simulation so they could be prepared for it when the guys actually did the work. And it was the same with the tooling equipment. There'd never been the tools to actually pull this stuff out. There's a lot of remote operated work going on here. You can't go into that reactor when it's got all this radioactive material in there. So they did all this tooling work and training the guys to use tooling and so on and so forth. Huge amounts of investment in learning and understanding how that work was going to be done. And what I want to try and challenge here, this is a couple of slides to go off a bit of a tangent here, is that there was this conceptual model of work as imagined, and then there was work as done, and yeah, there's always a problem with work as done. That's me making an excuse for why I couldn't get the text to go upside down. There's these two conceptual models, right? You get it now. And this is what I advocate for. When these two conceptual models overlap, we get an area in the middle. The area in the middle is what I would call trust. We've now got an agreement, social agreement or cognitive agreement, that these two things match, and therefore work as imagined, work as done, they align. There's all sorts of issues with that, and I'm not going to go into that in the time we have. But what I'm interested in is where there is differences or variations, they become triggers for learning. And this was something John Green, if you're familiar with John Green, he was my boss back in Canada, one of the things that we changed our approach to. We no longer talked about positives and negatives, failures and success, because that's too abstract. What we were interested in is variation. So you say maintenance means that. What do you mean? Okay, that's different. Why do you believe maintenance is different to you? Let's explore that a bit further. Let's find out why. And what we were interested in was trigger words. These are words that were synonymous with variation. So better, worse, more, less, unusual, stupid. Oh no, it's not stupid. That's old way of thinking. Strange, weird. And when people throw it into a conversation, we were following it up. We're like, that's interesting. Why do you say it's strange? Well, strange is synonymous with, is different, right? It's variant. So we didn't have to be doing anything and spending lots of money on this stuff. We could just listen to what people were saying. I'm going to have to quickly go through these slides because I don't want to go for too long. But when I started to think about simulation of work as an engineer, I was a civil engineer for 15 years before I moved into safety. This is what we would do to simulate work. Every engineer I knew had an illegal copy of AutoCAD. Okay? If there's any engineers in the room, you know exactly what it was, still from university days. And because we didn't have the tools for the job, we would just sit there and we'd map out. So there's the crane, there's the pad foundations, this is where we're going to go, there's the radiuses, da-da-da-da-da. We'd simulate it in 2 dimensions. And it gave us a better understanding of where the right positioning of the crane would be and whether we would clash with anything else. And this is a tandem lift that I did years ago. And in reality, that's the kind of confined space we had to deal with. It's a very congested site, but being able to simulate it prior to that, we could work out the crane positionings that would be optimal. And then we had it all sprayed out for the guys. It just turned out, rocked up, job done, and away we go. And it was a form of simulation. Now that's 15 years ago. This is another job I won an award for in the UK as a civil engineer. And as the contractor on site, we were putting a whole load of what we call raked piles. They were an angled pile down the back of an existing flood wall, which you can just see there on the left-hand side. Now, at an angle with a ground level that's continuously changing up and down, depending on where you have the ground level will depend where you start your pile. And then you've got the overhang there, and so you couldn't figure that out without sitting down, simulating it, doing calculations, getting your CAD out, your illegal copy, and trying to figure it all out. How are we going to make that work? So you can't achieve engineering feats like that without good simulation and good buy-in from all of the crew. How big is the rig? How much space do you need? Where are the hoses going to be? What are we going to do with the slurry when it comes out? And of course now, I mean, I took a bit of time out of safety. I kind of lost my way. I think many people get to that point in their safety careers and go, oh, jeepers, what are we doing? And I went back to engineering and then realized, oh, I need to help try and change this because it's not working for me. And it was the first time I've been exposed to BIM modeling for those of you in construction. So it's 4-dimensional modeling. It enables businesses and contractors and steel fabricators and all the utilities guys that are working in that building to create a 3-dimensional model in real space and go and make adaptations to that model. It meant that we were able to, difficult problems like this geometrical issue here, this connection, we weren't putting that in front of the guys on site, them then saying, how the hell do we bolt that thing together? Oh, by the way, it's up at height, I'm in a cherry picker, I'm not going to be able to get that bolt, I'm not going to bother tightening it all the way. Oh, but I've got a wrecking bar, which is not an approved tool, so we'll start using that, or we'll get the burning torch. Before you know it, you've got financial issues, quality issues, safety issues, all brewing from something that we could have simulated earlier on. And this is how we started to change and get clever. And construction is getting much, much better at this space. about simulating what work will be like and what are going to be the requirements. And that fits really into that anticipation piece. This is Andrew. He looks like the Joker in this picture. But last week, we're just curious explorers, is what I'm calling the term now. We were over with Oricon in New Zealand last week, and just as we were calling an end to the day, we came across this. And we were saying, like, we should use this next week. How fascinating is that this sandpit is creating contours and so forth?
It's an adult sandpit. Oh, wow, look at that.
I've absolutely no idea how you're going to use that in the future. But, you know, it's still a form of simulation. It helps us to create an idea of what it is going to be. And I've lost where Eric is, actually. Is Eric even left? Is he still here? Eric has used a huge amount of metaphor and analogy in these last 2 days as a means of communicating some of our ideas and concepts. And it's precisely what I'm calling for in terms of we can take learning and update a conceptual model, one that's going to be appropriate. You don't want it to be too complex because people won't get it. And I will do a lot of work with the search and rescue teams in New Zealand, and the same thing again. These guys don't rely on heaps and heaps of paperwork, but they do create a lot of scenarios, a lot of simulations, and they look at what does and does not go well. And you'll often see assessors at the side. They're not assessing, but they're reviewing how that process is going. How can we get better? What are we doing? It's a form of ethnography in many ways. And I'm really fortunate. I've done all sorts of stuff, right? There's a biscuit company. I don't know what the company's called again. What are the biscuit companies here? To who? Yeah, them. Did you see this thing where this guy ran around and did a whole load of weird stuff and he was fighting the doughboys? Did that come out over here? It came out in New Zealand. These guys spent a fortune. They hired the SS Earnslaw down in Queenstown. And we said, yeah, you can do this stunt. And he basically wanted to jump off a moving steamship. And I was like, yeah, we can do it. Work through with them. But I can tell you now, they do not do that once. Or they do the jump once. But they rehearse and they rehearse. They're checking the camera angles. They're looking for it to be right. Now, I'm not proposing we do that, but we can do that in a simulation. So my challenge to you, and this is the challenge, is that we don't necessarily have the money to do all that simulation stuff right now, but we can simulate that through conversation. And so my challenge to you then is, what if we change the questions we asked to better simulate work before it actually starts? Because anecdotally, what I see is a lot of people do risk assessments and will focus on what could go wrong, and there'll be much more emphasis on that than how we're actually going to get the job done. I'm not saying that they're separate to one another, but if we want to understand normal work, we need to understand what the constraints are, what the conceptual model of work will be.